Hello and welcome to this higher tier GCSE lesson on cylinders. Firstly, your do now task is to calculate the surface area of the following shapes. A reminder that means you'll need to calculate the area of every face, including the ones that you can't see. Show all you're working for this and pause the video while you work through it. Okay, let's check the answers then. The first one is 42 centimetres squared. Then we have 64 centimetres squared, 408 centimetres squared, and lastly 320 centimetres squared. Okay, so we are looking at cylinders today. And we're going to look at how to calculate the volume and the surface area, and then we'll have a look at some problem solving questions. So a cylinder can be thought of as a circular prism. We saw it last lesson on the prisms topic. So we saw that we would have to calculate the area of the face times by the length. Now usually with a cylinder, we draw them the other way around and call it the height. So this time we have a specific formula. So write this into your exercise books. V for volume, so volume of a cylinder, equals pi r squared h. Okay, we're going to use this to do an example which you're going to copy down. Now, if you don't want to copy the words of the question, sketch a diagram and it has all the information there. So we're going to calculate the volume. Therefore, using pi r squared h, we're going to have pi times by 5 squared times by 12. And that will give us 942 centimetres cubed to three significant figures. Now, for the questions that you're going to work on, you don't need to write down the formula every single time unless you want to. Make sure you've got the working as well as the answer. Okay, you're going to have a go at these. Write down your working as well as the answer and pause the video while you work through them. Right, let's check the answers. Question 1A should be 226 centimetres cubed. Notice all these questions were to three significant figures. B is 14.9 centimetres cubed. C was 346 centimetres cubed. And D was 1060 centimetres cubed. You also should notice that B and D, you are given the diameter, so just check carefully there if you didn't quite get the right answer. Question 2 said to give your answer in terms of pi. So the first one, A, is 72 pi centimetres squared. You still need to have the units on there. B is 112 pi centimetres cubed. C, 180 pi centimetres cubed. And D, 600 pi metres cubed. Now those could all be non-calculator questions since you're giving your answer in terms of pi. So make sure you're able to work that out without a calculator. Okay, moving on to the surface area of a cylinder. So we've got two circles and we've got a curved part. If that curved part opens out, it becomes a rectangle, where h is the height of the cylinder and c is going to be the circumference of the circle. So if that was folded round, it would make a circle. So this is the formula and we're going to copy it into your exercise books. So for the surface area of a cylinder, we've got 2 pi r squared plus 2 pi r h. So that comes from having two circles, so two lots of pi r squared. And remember the circumference is 2 pi r, and then we've got h. So 2 pi r times by h to give us the rectangle. We could also have a look at it in terms of pi d for the circumference, but generally, since we need r for the radius for the surface area anyway, we will use that top formula. Okay, let's have a look at an example. Again, a quick sketch of a cylinder might be a bit quicker for you to do than to write out the whole question. So a quick sketch gives us 15 centimetres on the radius and 2.5 metres for the height. Now notice that the units are different here, so make sure we change the dimensions to a common unit. In this sense, it makes the most sense to use centimetres, so that we don't have to be dealing with any decimals. So a reminder of the formula. First thing we're going to do is write down our substitution. So the surface area equals 2 pi times 15 squared plus 2 pi times 15 times 250. And that's come from 250 centimetres, which was that 2.5 metres. Now, if we were to be asked to do it as a non-calculator question or answer in terms of pi, we could write out these next steps. So we could work out that first part is 450 pi and the second part is 7,500 pi and add them together. However, this time we are asked to give our answer correct to 3 significant figures. So that's the value we get on the calculator, and then we round it, we get 25,000 centimetres squared. Just remember, this is area, so it is going to be centimetres squared. Now, the minimum amount of working you should be doing is this line here, the first line. It's always really useful to write down the value from your calculator just in case you make an error with rounding, and then write the final answer. Okay, you're going to have a go at some of these now. So these are the same cylinders as before, but you're now going to calculate the surface area. Notice for question 2 again that your answer are in terms of pi. So pause the video while you work through these. Right, question 1a is 207 centimetres squared. B, 61.3 centimetres squared. C, 275 centimetres squared. D, 636 centimetres squared. Question 2 are in terms of pi. So A is 48 pi centimetres squared. B, 56 pi centimetres squared. C, 60 pi centimetres squared. And D, 120 pi metres squared. So now we're going to look at problem-solving questions. So these are quite wordy and do involve other things at times. So what you need to do is have a look at the keywords, draw a sketch if that's going to help, and label the diagram. Pause the video while you work through these questions. Okay, let's mark these. So question 3, the first thing to do is to calculate the volume. So you've got to recognise that this question is looking at volume, not surface area. And then the cost, you were given the cost per cubic metre, and since we've worked out the volume in cubic metres, we're going to do that volume times by the cost, which gives us £80.16, which is close to £80. Question 4, you need to use that reminder at the bottom, and you're going to end up with 1.23 tonnes. And question 5, this is a surface area question, or an area in terms of the curved part. So you're looking at the circumference and you're looking at the height of the cylinder. So since the height is 10.5 centimetres, the label doesn't want to go over onto the top or the bottom of the can. But we do want the label to overlap when it's going around the can on the curved part. So we do want the label to be a larger length than the circumference of the circle, which is 23.3 centimetres. Okay, here are some more problem-solving questions for you to have a go at. Again, pause the video while you work through these. Okay, let's mark them then. Question 6, there is a hint there that 1 millilitre is 1 centimetre cubed. So if we have a look at the volume, we're going to have that in centimetres cubed. And then we can see that 1 litre is 1,000 centimetres cubed, knowing that there are 1,000 millilitres in 1 litre. So if we divide by 1,000, we'll get how many litres we've got, and then round that, and we get 332 litres. Question 7, there are many answers. All you really need is to come up with 2 values that when you calculate them, you're going to get 330 centimetres cubed. So one example of an answer is going to be 6.6 centimetres high and a diameter of 8 centimetres. But there are many other answers you could have. In question 8, you're going to end up with 7.78 grams per centimetre cubed. Okay, so we've had a look at how to calculate the volume and how to calculate the surface area, and then we've applied that to problem solving questions. Let's have one final question just to finish you off. Pause the video while you work through this. Okay, the answer is approximately 127 centimetres. Really well done if you've got that. Let's have a look at the working for it. So the first thing we're told is 1 centimetre, or it's the last thing really, 1 centimetre cube of metal. So if we put that in the way that we're used to seeing that written, it's 1 centimetre cubed. So we can see the units there. We can see the diameter is written in millimetres, so let's convert that volume into millimetres cubed. If we know the formula, we can substitute in. We've got the volume is 1000, and that's going to equal to pi multiplied by the radius is 0.5, and that's going to be squared, and then we're going to times by the height. So that is what we're trying to work out. So to get the height, we're going to do 1000 divided by pi times by 0.5 squared, which gives us this value. Remember, we're in millimetres, so that can be then converted into centimetres for your answer. Okay, well done today. That is the end of this lesson. I will see you next time. Bye-bye.